All right, here's what we're going to do. I'm going to do one more example with you, and then I decided I'm actually going to save the last example for tomorrow. Tomorrow's a work period, but we can throw an example kind of at the beginning of the period. Okay, you could start your assignment tonight. The problem that I'm going to save for tomorrow, it's like one of those examples that would be at the end of the assignment anyway. Okay, so again, we'll do a work period tomorrow, but I am going to do one last example. It'd just be better to not. There's sort of only so much of this you can kind of take in a period. But look at this example with me. It's quite a bit more involved. Basically, the whole derivative, the whole solving, and the last step, which is to analyze. And this hopefully will give you a little more of a reason why we need to be able to learn how to do this with calculus. To be able to analyze x to the 2/3 times x squared minus 2. And then we even have this little guy tacked onto the end where we're between -2 and 3. All right, so x to the 2/3 quantity x squared minus 2, and then -2 to 3. I'm purposely not using a calculator, but I do want you guys to understand that this is a graph, and we're trying to analyze that graph, but we are trying to analyze it, again, without just putting it in the calculator, okay? Although we might use a calculator somewhere along the way, let's try not to use it as much as possible for now. It's not a bad derivative if you just want to try it. I don't think you need to watch me do that derivative. Are you going to do the product rule? I hope I didn't give away all the secrets. So if you just want to try the product rule here and be a step ahead of me, I would expect you to get this derivative correct. But if you want to double check, yes, you do end up with a negative exponent, which honestly is what makes this derivative sort of destined to have some tricky steps with the simplifying. Are we okay with the 2/3 x to the -1/3? Okay, so again, we have to look at this and kind of say, okay, this definitely needs simplified because no one in here, including myself, can solve that equation equal to 0, not the way that it looks. Okay, so we're going to not even worry about that, but instead, let's do some exponent work. I like this here. It kind of takes you back to some of the basics. X to the first, x to the 2/3. You can add those exponents. If you add those exponents, you should be adding them like fractions. So x to the first is really like to the 3/3. The 3/3 plus 2/3 is 5/3. So we have 2x to the 5/3. Notice that the 2 was just a coefficient, so it didn't really affect that. How about over here? Over here, we have this negative exponent. Let me help you kind of sort this out a little bit. This is another reason why we try to get you guys to flip negative exponents so that they become positive. Notice that it's still 1/3. I didn't flip it to be like 3/1, but I did flip the whole thing so that x to the 1/3 is in the denominator. Now, I haven't done anything with this 2/3 because I wanted you to see the fraction, and hopefully to make things as easy as possible, to just place the 2 in the numerator and the 3 in the denominator. All right, that's a pretty good job just kind of cleaning up that second fraction. We're still not ready to set this equal to 0. So again, we're not ready to do that because we don't know how to solve when there's x's all over the place. Try to become the algebra student that says that we need to add these fractions. I'm talking about a common denominator. You need a 3x to the 1/3 to become the denominator of that first term. Of course, you can't just put a 3x to the 1/3 down there unless you're going to put it up in the numerator. Okay, so this is the common denominator sort of trick. What do you guys think? 3 times 2, yes, is going to be 6. But I'm letting you look at these x's. We have x to the 1/3. We have x to the 5/3. We now have x to the 6/3. You're going to add the exponents, 6/3. But 6/3 is the same as 2. It's a square. 6x squared. You're getting your daily dose of algebra right now. I'm going to save a step, I'm just going to distribute and get that 2x squared minus 4. 2x squared minus 4. I also decided to just put the fractions together so that we can just write the common denominator one time. 3x to the 1/3 in the denominator. All right. 8x squared minus 4 all over 3x to the 1/3. That's a much better derivative. I don't think we did a problem quite like that in the last chapter. Like, I never had an example where all that took place, but I know it happens a couple times in this chapter. Okay, because this is a perfect opportunity for us to think about the 2 little sort of arrows. It says when the derivative equals 0. Listen, the only time the derivative can equal 0 is when the numerator equals 0. The only time the derivative can equal 0 is when the numerator equals 0. But how about this undefined thing? We did it in the very first problem last week. But undefined would be when the denominator is equal to 0. This kind of goes against the grain because kids are like, I thought the denominator couldn't equal 0. Yes, that's why it's undefined. So I want to think about this. I want to solve. Okay, now I also want to solve this one. I hope you're adding 4 and dividing by 8. Okay, you get a half. You actually get x squared equals a half. That means that x equals, it's kind of strange that I'm going sideways here, but just if you can track with me, you're solving the numerator. X squared equals a half. That means x equals the square root of a half. And furthermore, plus or minus the square root of a half. Now, I'll share with you that that plus or minus is pretty important. That won't be the last time where you end up with a plus or minus for an x value, which when it comes time to make our list, it like doubles our list. This is 2 numbers. So make sure that you get the plus or minus from taking the square root. Normally, the square root gets kind of like repositioned, right? Don't you take the square root of the top and the bottom? So we actually get root 2 over 2, plus or minus root 2 over 2. I took the square root up to the top, something that you would have done in geometry or even in your trig class. Just ask. You guys are here, so I hope you ask if you're not sure what I did. So it was this, and then I kind of like separated the square root, but then that's like a no-no. You can't have a square root down there. Multiply top and bottom by root 2. It turns out it cancels to be 2, and then the square root just bumps up. Okay, careful. You know, solve this equation for x. Divide by 3. Okay, divide by 3. So you get x cubed. Check that. X to the 1/3 equals 0. Again, solve this equation for x. Okay, now at this juncture, technically you would cube both sides. When you cube both sides, you cancel the exponents. But you really just end up with a big fat 0. But again, I cubed both sides so I could get x equals 0. I want you to realize that this is a graph, but I don't want you to just graph this and basically use the graph to come up with these numbers, okay? Because honestly, we want to learn the calculus, and I want to see the specific number. I want to see like the exact x value. If you just put that in your calculator, you get like an approximate x value. So we want to see this. Okay, but I want you to realize that there is a graph that's sort of like lurking in the background. Let's organize our thoughts. I see some of you kind of using this strategy. Yeah, I want you to organize your thoughts however it's going to work for you. I'm kind of putting these x values, I'm putting them with a y value. Obviously, I have not written the y value yet, but we're just kind of getting ourselves organized. When you guys finally take the test or the quiz or do your assignment, don't forget about the endpoints. They can be forgotten because you will do all this calculus. This one had a little more calculus, and you're like, that was a really good job. But then we kind of get carried away and forget that the endpoints are part of our list. Listen, the endpoints will always be part of your extrema. Let me say that again. The endpoints will always be a part of your extrema. All right, and now it's time to sort of like finish. Now, this is kind of the part that I hate. Well, I don't hate, but it's kind of annoying, where you technically have to plug back into this equation, okay? Like, you have to plug in these x values. 0 is easy to plug in, because as soon as I plug a 0 in right there, everything equals 0. So we didn't really have to use a calculator for that. The rest of them, you're probably going to have to use a calculator. Okay, now kids are like, I thought you said don't use a calculator. I'm trying to train you how to do this without a calculator, and eventually when we put it all together, you'll see that we don't need a calculator for everything. But I guess I need a calculator to plug these numbers back in for x. I'm not going to do that up there, and I can tell that you're just kind of waiting for me to show you, but make sure you know how I'm getting these y values. I'm getting, let me make sure I get this right, negative 119. Negative 1.19. That's for root 2 over 2. And then you end up with another negative 119. Yes, you get negative 119 again. And again, I plugged into the original equation. And finally, when you plug in negative 2, you get 317. And when you plug in 3, you get 1456. That doesn't have a lot of pizzazz to it. It's just some y values. Good.
How do you get the 0 to the y value from 0?
Well, basically 0 to any power.
Oh, never mind. I see it.
And then you're multiplying, so I mean it's going to be 0. That's good. I'm glad you're asking. We got a lot of extrema here. Okay. Well, one of them looks like it's definitely the biggest, so we can sort of grab onto that. I'm serious. That's the biggest y value. This has to be a maximum. A couple of them look like they're the smallest. I know it's like a tie. but negative 119 is the smallest y value. So this definitely has to be the minimum. Now, what am I doing? Is giving you a little bit of a preview of something that you guys will soon connect. Now, what I'm really doing is just plotting the points, but I'm trying to give you a little sneak peek. It's something you will soon be doing. You decide if you want to rewrite all the points or if you just want to put 5 points on a sketch. I just wanted to make sure you knew how I'm getting them. Now, you guys are like a little young at this. You're, what do they say, like sort of wet behind the ears. But take a look. If you connect these dots, you will eventually realize, because we will learn one more thing, that there's only one way to connect them. Now, when you connect these dots, and as I said, there's really only one way to connect them, you start to see what would have to be true about these points. What would have to be true about these points? Now, I'm connecting them, but you soon will be that person that also connects them because there'll be one more thing that I'll show you. But just take a look. It has to be true. It has to be true that 0, 0 is a relative maximum. Okay, it's the only way that the dots can be connected. It's a relative maximum. By the way, you've noticed maybe that I've not mentioned that word relative really since Friday. I don't make you say relative and absolute when you're doing one of these problems without a graph. If I give you the graph and it intentionally tells you to say absolute or relative, then you say so. But if we're just given an equation, okay, you don't need to say relative and absolute. You can just kind of be generic. Oh my gosh, what did I do here? I was talking about 0, 0, and then I wrote it right there. 0, 0 is a maximum. Okay, now so is negative 2. Negative 2 is also a maximum. It's a high point. This equation is kind of scary, but when you do the math and you think about a sketch, there's only one way that it really can go. And we sort of have calculus to thank for this, at least mainly calculus. We also have some y values. The y values were obviously pretty helpful too. All right. There's one more problem. Like I said, we'll do it at the beginning of the period tomorrow, but you could start your assignment, and this is a good stopping point for today.